All right, here we go today. What we're going to do, I gave you this worksheet yesterday, and you're going to go through it and check your work. Now, if you weren't here yesterday, if you were on the Avid field trip, that's okay. You're going to go through and you're going to have a chance to do the problems. So everybody will get something out of this lesson. What I'm going to ask you to do is check 3 problems at a time, and then if you get the answers right, go check 3 more problems. But if you get the answers wrong, look at them and think, okay, what mistake was I making? And then go back and rework some problems. Now, obviously, I can't make you do that. Nobody can babysit you to do it. This has to be a place where you start deciding you're going to do the things you need to do to be more successful. All right, with that in mind, here we go. First 3 problems. So the very first problem was one that we did in class, but we'll go ahead and do it together for this activity. So we had 3n minus 5 equals 19. My very first step is to go ahead and draw this reflection line. Now, if you weren't here yesterday, this is going to be new, but that's all right. This is a continuation of work that you started last week. So when I look at the 3n minus 5 equals 19, what I'm thinking of is, what if I had this mystery box called 3n? It had some amount in it. I don't know how much, but it had 3n as the label on the box. What I do know is if you take 5 away, you end up with 19. If I want to figure out what that is, probably the first thing I'm going to say intuitively, not just do the math, but the first thing intuitively that I'm going to say is, well, I've got to put the 5 in to the 19. I've got to add 5 to the 19 because that'll tell me what this totals. That's exactly what we do here. Since 5 is being taken away, we would add 5 to both sides. Remember, the reflection line tells us whatever you do to one side, be sure you do it to the other. So these would cancel out. The minus 5, let me change up my color on that. The minus 5 and the plus 5 would cancel each other and would leave us with 3n. The 19 and the 5 would add together to give us 24. Now I know that this box that has 3n has 24 in it. Well, if it has 3 n's and I want to know how much each individual n is, I'm going to divide by 3 because that tells me what 1 n is. 1 n would be 8. I can check my work to see if that's true by saying, all right, if I had 3 and I multiplied it by 8 and then I took away 5, would I get 19? Well, 3 times the 8 is 24. That 24 should look familiar. It's right there. It's what we had before we divided by the 3. 24, take away 5, is indeed 19. And that tells me that I did that first problem correctly. That was problem S. Let's move on to problem O. For problem O, we have 4x plus 2 equals 14. Once again, going to have our reflection line. Once again, our goal is to get x by itself. We want to know how much does x equal. So my first step in doing that is I'm going to take away the 2. I'm going to take away the 2 from each side. This cancels out, totally gone, which means the only thing remaining here, I've got 4x plus 2 minus 2. They cancel, so I've got 4x left. On the other side, I had 14 and I took away 2, so that gives me 12. So I know that 4x's are equal to 12. If I want to know how much 1x is, I would divide by 4. When I divide by 4, this becomes a 1 right here, 4 over 4. So there's the x I have left. 12 divided by 4 is 3. I can check my work by saying, does 4 times 3 plus 2 equal 14? Well, 4 times 3 is 12, and 12 plus 2 does equal 14, and I can be confident about the work I did. And again, if I take a look at that 12 I got from the multiplying, that's the 12 right there. That's where it was before I divided. All right, last one. Letter C. 9y plus 10 equals negative 8. Once again, reflection line, so I remember whatever I do on one side, I'm going to do on the other. Since I'm adding 10 to the 9y, and I want to know, my first step is to know what's the 9y equal to. In fact, I can even think of that. I can say, you know what, the first thing I'm going to want to know is, what does 9y equal? Well, to figure out what 9y equals, I have to take away the 10. Over here, I have to take away the 10. These cancel out. And these are going to end up being negative 18. If you need a reminder on that, remember, if I say negative 8 take away 10, I can think of that as negative 8 plus negative 10. Well, 8 negatives plus 10 more negatives would give me 18 negatives. So now I know that 9 y's are equal to negative 18. I want to know how much is one of those y's. So I'm going to, let me get rid of my not so good looking 9 there. There we go. I want to know how much just one y is. So I'm going to divide by 9. 9y divided by 9. If you had a group of 9 y's and you divided them into 9 groups, every individual y would have its own group. Negative 18 divided by 9 is negative 2. And if I check my work, does 9 times negative 2 plus 10 equal negative 8? Well, 9 times negative 2 is negative 18. And yes, if I have negative 18 and I add 10, I've got 10 zero pairs right here. These 10 positives cancel out 10 of the negatives, and they leave 8 of the negatives. And that is also success. So now I'm going to go put these 3 answers into the puzzle. So for S, I have 8. For O, I have 3. And for C, I have negative 2. So if I go back to the puzzle, for S, I had 8. For O, I had 3. And for C, I had negative 2, which means everywhere 8 appears, which is right up here somewhere, there should be an S. Everywhere 3 appears, there should be an O. Is there a 3 right there? I wouldn't be surprised if there were more than one, because O is a popular vowel. And everywhere C appears, there's a negative 2. Or excuse me, everywhere negative 2 appears, there's a C. So negative 2 there, and that's my only negative 2. All right, so I'm going to go ahead and I'm going to do the next 3 problems, but I would encourage you, if you need to, pause now and go back and redo those 3 problems. All right, here we are with the next 3. So, problem E. 2a minus 15 is equal to negative 1. So I'm going to add 15 to both sides. Notice each time I'm doing the opposite of what's happening to the constant. Let's remind ourselves, this value, this one that does not change, is called the constant. I'm doing the opposite of the constant. Here they're taking away 15, so I'm adding 15. That will allow this to cancel out, leaving me 2a. Negative 1 plus 15 is 14. So I know that 2a is equal 14, but I want to know, what does 1a equal? Well, I'm going to divide my 2a's into two groups. If I divide 2a's into two groups, each group has a in it. And if I divide 14 into two groups, each group has 7 in it. Is that right? Well, let's find out with our check. Does 2 times 7 minus 15 equal negative 1? Well, 2 times 7 is 14. Does 14, let me write it just the way it started out, does 14 minus 15 equal negative 1? Well, I would think of this as 14 plus negative 15. I would change it to addition. And yes, if I have 14 positives and I add 15 negatives, I get 14 zero pairs and I have 1 negative left over. All right, problem T. So in problem T, we have negative 5x plus 7 equal to 27. Again, we're going to start with our reflection line. That reminds us whatever we do on one side, we do on the other. I want to know, eventually I want to know what x is. I can go all the way down here. X equals something. Along the way, I'm going to want to know what negative 5x is. So if I think of my goal as being how much is negative 5x, that helps me recognize that I need to get rid of the plus 7. I need to do the opposite to cancel that out. So I put in a minus 7, and that cancels the plus 7, and I have just the 5x. Only the 5x, or the negative 5x, I should say, remains. Now remember what the reflection line tells us. Whatever you do on one side, you have to do on the other. So I have 27 take away 7, which gives me 20. So I know that negative 5x is equal to 20. Again, my goal is how much is x itself. So I'm going to divide by the coefficient. Negative 5x divided by negative 5. Let me blow that up right up here. If you have negative 5x and you're dividing by negative 5, really what you're saying is I've got negative 5 times x, because negative 5x means negative 5 times x, all of that divided by negative 5. Well, these cancel out. Negative 5 can go in negative 5 once, and negative 5 can go in negative 5 once. You can think about it that way to get 1, or you can say, let me get rid of those, or you can say, well, that's like having the fraction negative 5 over negative 5 times x, which is the same as saying I've got 1 times x, which is x. So that's why this leaves me x. When I do negative 5x divided by negative 5, I'm to my goal of x equals. I can move this up now. I'll leave room for that important check I'm going to do. I also have to divide this by negative 5. So positive 20 divided by negative 5 is going to be negative 4. If you divide a negative into a positive, signs are different, your answer will be negative. And here's where the check is super important. The check will tell you if you made a mistake. Let's say that you did this and you said, I get 4. So then you check with 4. So then you stick in a 4 and you go negative 5 times 4 plus 7. And then you remember negative times positive, that's negative 20 plus 7. Does that equal 27? And then you realize, wait, there's a problem here. I've got 20 negatives and 7 positives. That makes 7 zero pairs. That would be negative 13. That would not equal 27. There's something wrong. That would cause you to look back into your work and say, oh, there's something wrong. I divided 20 by negative 5 and got 4. I should have had negative 4. Now let me go back to my check. Let me get rid of those two things, get rid of that, and say, what if I put negative 4 there? Well, if I had put negative 4, I'd have negative 5 times negative 4 is 20, because the signs are the same, and 20 plus 7 is 27. Now I can be comfortable with my answer. So the answer to this one, negative 4. The answer to this one, positive 7. All right, we have one more on this page, then we'll go put those answers in to the puzzle. And then it's just about time for me to stop and let you keep working some on your own here. We're going to do problem I. So for problem I, we have negative 8w plus 4 equals negative 36. Put my negative sign a little bit higher here because I want you to remember that's a negative 8w. Because sometimes students say, well, is that a subtract 8w? No, there's nothing to subtract it from. It's the very beginning of the math sentence, so it's a negative 8w. So we have our reflection line. My short-term goal is to find out how much is negative 8w equal to. So to do that, I have to take away that 4. When I take away that 4, it cancels out adding the 4, and I have negative 8w. And what does it equal? I got to write that a little bit better. I'm not happy with how that looks. So that leaves me with negative 8w. All right, well, since I took 4 away here, I have to take 4 away here. So I have negative 36 minus 4. I'm going to think of that as negative 36 plus negative 4. Because anytime I set it up as plus like this and I see everything's a negative, that helps me realize my answer is also a negative. I'm putting these negatives together. The mistake sometimes students do right here is they go, oh, negative 36, take away 4, negative 32. Now you're adding 4 more negatives. So I have negative 40. That's how much negative 8w equals. I want to know what just w equals. So I'm going to divide each side by that negative 8. And I'm going to end up with w equals negative 40 divided by negative 8 is equal to positive 5. So I know that I had negative 8. I said my answer is negative 5 plus 4. Does that make negative 36? Negative 8 times, oh, excuse me, I made a mistake right there. I wrote negative 5. I said my answer is positive 5. Negative 8 times positive 5 is negative 40. Signs are different. Answer is negative plus 4. Well, if I do that, negative 40 plus 4, I've got 4 zero pairs. So those 4 zero pairs mean these 4 positives cancel out 4 of the negatives, and they leave 36 negatives, which is the answer. And I'm done. All right, so E was 7, T was negative 4, and W was 5. So 7, negative 4, and positive 5. So everywhere there's 7, there's an E. So there's an E, There's an E. There's another E. There's another E. Was there another one somewhere? If we come to it later in the puzzle. If I missed it and you didn't, that's great. Everywhere there's -4, there's a T. There's one right there. I'm surprised there's only one T. T's are usually more popular than that. And everywhere there's a 5, there's an I. I would expect to find a lot of those. Wow, just one. That's surprising. Only one 5. Only one I in all those letters. All right. So now it's time for you to pause the video. If this helps you with some understanding of the problems you didn't understand how to do, please go through and do some problems on your own and then turn the video back on to see solutions. If all you do is listen to me solve problems, just watch me, you will not learn that much. All right, let's go to another set of problems. So problem A. Problem A has 11 plus 6k equals 65. So by now, you should see the pattern here. We're going to put the reflection line in, and we're going to be thinking about how much is 6k. That's our first thought. Our overall thought is how much is k. But first we're thinking how much is 6k. So to get the 6k, since this is 11 plus 6k, this is 11, we need to take it away. We need to get rid of the 11. We do that on both sides. That cancels out. 6k comes down because that's what's left. And over here, 65 take away 11 is 54. So 6k is equal 54. What does 1k equal? Well, we're going to divide by 6 to find out. 6k divided by 6 is k. 54 divided by 6 is 9. Let's see if that's right. Does 11 plus 6 times 9 equal 65? Well, that's 11 plus 54 is that 65. And here's a sign that we're on the right track. That 54 is what we had right there before we divided by the 6. And yes, 11 plus 54 is 65. And you can feel confident with that answer. So when I get back to the front of this, I'm going to feel confident putting the 9 into my answer box. All the 9s are going to be A's. And I would think there'd be a lot of them. A is pretty popular. All right. Letter M. 7 plus 3m equals -29. So this is going to be another place where we're starting with a negative amount. And we can probably guess that this m has to be something negative. We know it actually has to be something negative because this is a positive and this is addition. The only way we're going to get a negative over here is if we're multiplying by some negative amount. So our first question is going to be to figure out what 3m is equal to, and then eventually what m is equal to. Well, to find out what 3m is equal to, we have to take away that 7. We have to cancel out the 7 that was sitting there with the 3m. We have -29 minus 7. I'm going to take this up here because this is one of those that can be confusing. -29 minus 7. So a common answer here is 22. 29 take away 7, 22. Again, if you take a moment to change this to addition, -29 plus -7, you will see, oh, we're getting a lot more negatives. We have 29 negatives already. We're getting 7 more than that. we're going to have 36 negatives. So our 3m is equal to negative 36. So if 3m is equal to negative 36, how much is 1m equal to? Well, let's divide by 3 and find out. 3m divided by 3 is m. Negative 36 divided by 3 is negative 12. And I can prove this to myself by saying, does 7 plus 3 times negative 12 make negative 29? Well, 3 times negative 12, 3 times 12 is 36. So 3 groups of negative 12 would be negative 36. So I would have 7 take away 36. I would probably change that to 7 plus negative 36, because as soon as it's addition right here, then I can think of 0 pairs. I have 7 0 pairs here. These 7 cancel out 7 of those negatives. They leave 29 negatives right there. 29 negatives. All right, so I can be confident when I get back to the front that negative 12 is the answer for M. Last one. Letter D. Now, letter D, we worked on that in class summit. Letter D created a lot of questions. So let's make sure we do D here together so that you get those questions answered. Looks kind of confusing. We have 1, we're taking away 10x. It's all going to equal 81. Reflection line. Make sure I remember whatever I do on one side, I'm going to do on the other. My first question is, how much is negative 10x? This is a place where I would definitely change this to 1 plus negative 10x, so that I know negative 10 is my coefficient. I know that my first goal is to find out how much is negative 10x. I've got this 1 out here. The opposite of having 1 is taking away 1. So I'm going to take away 1 on each side. This is going to cancel. Negative 10x is going to come down. Over on this side, when you have 81 and you take away 1, you have 80 left. Now again, remember, the goal is find out what x is. So I have to divide by negative 10 on both sides. This is critical. Common mistake would be to say, well, I'm going to divide by 10. But if you divide by 10, if we take this up top and think about it, if you had negative 10 times x and you divide by just 10, well, negative 10 divided by 10 is negative, would be negative 1 times x, which would be negative x. That's not what we want. We want x. So we have to divide by negative 10. That's the coefficient. So you divide both sides by negative 10, and you get negative 8. We can check it. Does 1 minus 10 times negative 8 equal 81? So does 1 minus 10 times negative 8 is negative 80. Does that equal 81? Subtracting a negative is like adding, so that's like saying is 1 plus 80 equal to 81, and that's probably a problem you were doing in 4th grade. That's absolutely true. So I can be confident with my answer of negative 8. So 9, negative 12, and negative 8. Let's put those into our puzzle. Spinning, spinning, getting back. There we go. So 9, negative 12, and negative 8. So everywhere you see a 9, it's an A. There should be, I would expect to have, not the negative 9. Don't fall into that trap. Oh, there was one more right there. Everywhere you see a negative 12, we're going to put an M. So I wouldn't expect as many. Looks like we have just one there. And everywhere you see a -8, we're going to put a D. So there's a -8 right there. And it looks like the only -8. All right, we're halfway through. And we're more than halfway through the video because I don't want to make this video too long. So what I'm going to do for the remaining problems is I'm going to do the group of 3 and then show you the answers, and you'll have a chance to check your work. And we'll do that with the last 9 problems, the last 3 groups of 3. Okay, here are our next 3 problems. So problem H, you can see the steps on that. And then problem U. You can see back on H, when I had that step of -75 minus 2, I changed it to -75 plus -2. So there's U, and there is W. So we end up with those 3 answers: 11 for H, -6 for U, -1 for W. If we look back, 11 for H, we had 11 needs to be an H. Let's get our answers written in. We have an H there. We also have an H there. U is -6. So where do we see a -6? There's a U there, just one of those. And a W, I wouldn't expect to find more than, well, actually there's a couple of them. There's a -1 right there and a -1 right there. All right, again, if you feel like you're confident and you're going along really well, keep watching the video. If you feel like you need to stop and do some work, pause before you go any further. All right, here are the next 3. Letter F, we got the answer of 10. Letter P, we got the answer of -13. And here was another step where we had -7 minus 19. Change it to -7 plus -19. Then it's really clear that it's going to be -26. I saw some students earlier working that problem, and they were getting 12 or -12. They were doing 7 minus 19 or -7 minus or plus 19. So changing it all to addition can certainly help. And then finally letter L, -3. So let's take those 3 answers forward: 10, -13, and -3. -13, -3. So all the 10s are F's. All of the -13s are P's. So there's one, and looks like the only one. And all the -3s are L's. So there's an L, there's an L, there's an L. Boy, that's sure a popular letter. Any more -3s in here? All right. Got a lot of letters left, but I have a feeling there might be some spaces in this. We'll find out. All right, here are our remaining 3 problems. So letter R, the answer is -20. And you can see here again the idea of changing this from -3u to plus negative. That helps you keep in track the idea that that coefficient is a -3, so you end up dividing by -3, gets you down to -20. Letter R, pretty straightforward. Your answer's 2. And the last one, B. And you'll notice with B, what I decided to do was I decided to put a 1 in front of the x. The original problem right here is 6 minus x is 15. I decided to make it 6 minus 1x, because what that does is when the 6's cancel out, I subtract a 6 from that 6, what comes down is this idea of a -1 coefficient. So I know what to divide by. If I just have a negative x sitting there, it's kind of like, what do I do with that? But if I put a -1 in, then I know I'm dividing by -1 on both sides, and I end up with -9. Let's go to the puzzle and see what those last three things give us. -20, 2, and -9. So to the puzzle, -20, 2, and -9. Every -20 is going to be an R. It seems like I saw several of those. There's an R. There's an R. There's an R. Any more R's? Nope. The 2's are all N's. So there's a 2. French. That makes sense. This is about somebody French. There's a 2. And there's a 2. And finally, all the B's are going to go where we have -9s. So -9 and -9. All right. So why did Pierre-Jacques Marseille feel at home in a bakery? Because he was French bred. Get it? French bread. Why do they call the famous what do they call the famous French general who kept dynamite in his kitchen? Linoleum blown apart. So kitchens have linoleum on the floor, and a bomb blew up in a kitchen. Get it? The math is better than the puns, but that's all right. Here the general is right there looking at all the dynamite in his kitchen. So hopefully you have a much better handle on solving two-step equations now that you've done this. If you need to go back and review any work, please do that. And you might even go back and include some of these problems in your test notes when we get ready to take the test on this chapter, which is coming up relatively soon. Okay. Thanks again. And as always, if you have questions, be sure you ask them in class.